Welcome back. This is Codeforces Round 903 Div 3. We're going to solve the third problem that is called as perfect square. So let's understand the problem first. We have a friend called as Christina, and she has a matrix of n by n, and the n size is always even. Now she wants to replace some character in the matrix such that it becomes a perfect square. How does she define a perfect square is, she has a matrix. If she rotates it by 90 degree, the original matrix and the rotated matrix both are same. If that is the case, then it is called as a perfect square. So how does the rotation work? In mathematical terms, the ABCD is the original matrix, means if you rotate it by 90 degree one time, the row becomes the column, this row becomes the column. So the first row becomes the last column and the last row becomes the first column. So that is the term. So they are defining operation. How do we replace the characters? So in one operation, Christina can choose any cell value and replace it with the next character in the alphabet. So if she reaches the end of the alphabet sequence, that is it, she cannot do anything. Values does not change. So if she has B, if she wants to convert C, means it is one operation. If she has B, she wants to convert to E, means C, D, E, right? There are three operations. So only for one stepping up one character only, it is one operation. If she wants to step up more characters, the difference of both the characters will be the number of operations. So for example, they gave a matrix like, our goal is we need to find the minimum number of replacements needed in the original matrix so that after rotation, the value will be a perfect square. Original matrix and the 90 degree rotated matrix should be same. Here we got a matrix here. What did they say? Here B, if we rotate it, it is not a perfect square. But if you replace this B with C, with one operation, they are telling that if you rotate it, it becomes a perfect square. So that's what they told. It is enough to apply one operation to the letter B so that it becomes. Now this is the example that they give. Let's try to figure out ourselves first, then let's see the other examples if we are unable to do. Now what is the first thing? I took a matrix like ABDC and I just assumed that these are the positions and I'm just trying to rotate it. So 90 degree rotation is giving me something like AB is written as column, DC is written as column, this row is written as column. Now what is the first thing? In a perfect matrix, it should be the exact copy, right? Both of them should be same. So let me take B here and let me take A here. B here and A here in the rotated matrix, it should be same. So at least one of the character I need to change. So whom will I change? I cannot change B to A because they told always it should be the next character that is possible. So what will I do? A can be converted to B. Now this is like the rotated one. In the original one, whom am I actually comparing it with? If B is here, A is on the left side, right? So this guy needs to be changed to B. I'm stepping up to one character. So what did I do here? If I'm comparing this guy and the rotated guy, means I'm comparing these two characters. So that is, in reality, I'm comparing these two characters and want to make them same. So that in the rotation also it will be same. Now, let's go to this guy. We converted it to B and we converted, here we have D. What will I do? D can't be decremented. So this B needs to be incremented, right? This B needs to be incremented means B becomes D here. Now, what did I do? If I'm comparing this character and this, means I'm comparing these two, right? This and this is what it is written here. That is, I replaced this A to B and I'm comparing this B with D and I say that these are not same. So I need to increment to the highest character. So that is D. So hypothetically speaking, in the original case, it is the adjacent characters here. So what happens? You take this one and we say that these two things need to be same. Okay, I converted this to D. Now let's consider this case, that is this D and this C. This C needs to be incremented to D, right? If this C needs to be incremented to D, both are not same, so I'm incrementing this. Whom did I compare? I'm comparing these two. So this becomes D. So what happened here? I'm just comparing these two characters. Now again, we need to compare this D with this B. If we are comparing this D and B, again there is a difference. So I need to convert this B to D. If I want to convert this B to D, I just need to compare with these two characters. So this is already D here. B is what? This D and B, there is a mismatch. This B needs to be converted to D. So here I am converting it to D. Okay. So now who all did I compare? I just compared with this guy and this guy. Now what happened? This is also D, this is also D, this is also D, this is also D. So what all things did we conclude? In order to see that two characters should be same in a matrix, we are comparing it with the adjacent element. If you see yellow colors, these two are same, these two should be same, this violet and violet should be same, and this red and red character should be same. How? So adjacent characters should be same. At last what happened? All the characters on this should be the same one, right? It's not like two characters can be different and other two characters. No, we should find a character that is same for everything. See here, D is already here, and we got all the D by performing the best operation. What is the specialty of D? D is the highest possible character among A, B, C, D, because they very well told that here replace with the next character in the alphabet. Obviously D can't be decremented, right? We want everything to be same. So A can be incremented to D, B can be incremented to D, and C can be incremented to D. If everything is DD, I can just rotate it. So there is one more case. So these are all the corners. So let's take this one, and this is one matrix. So we took corners. If I rotate it, all numbers should be same. Now what if the numbers are here? If this is here, this character becomes here, and if this is the one, then the next character will be here and the next character will be here. So this is just rotating here, right? This rotates here, and it will be just rotating 90 degree here. Now what if it goes here? If it goes here, the character will be 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 here. That's how the rotation is working. So the main observation is, you take four corners of that, four corners, the positions of all the 90 degrees, and make sure everyone is equal. If they are not equal, we need to take the highest possible character that is present and just take the difference of it. If you go from A to D, how many number of operations are needed? 3 operations are needed, right? Because A to B is 1, B to C is 1, C to D is 1, B to D, C to D is 1, and C to D 1 operation. So 2 operation here, 3 operation here, and 1 operation here. So total we have how much? 4, 5, 6 operations to make the matrix. So that's all. So that's all the overall idea. Now let's see how do we code it. So how can we prove this, right? We just very well know that since we just saw that by this matrix, we can very well see that everything is interdependent on each other. So we don't have to care about it. Every character should be same and it should be the highest element. Now the very hard thing is implementation part. How do you rotate a matrix? Now rotate a matrix is a very common problem in any programming DSA or anything that we are practicing on. So if this is ij, we very well know that this is n minus 1 and n minus 1, right? If this is 0, 0, this is this. So it should be n minus 1 and this is n minus j. Now if the element goes through this, column wise what should we do? Column wise the matrix value, the cell goes through bottom, and here the matrix value goes through left, and here the matrix value goes through top. So if we have ij, we need to relate this in some way that so that we will know what is the next position of that element. So it is very simple, like even if you don't get it, you can just find out on internet, like find how to rotate this, rotating a matrix in any internet forum. You'll be able to find out this is the common rule here, that is ij is 1, ij, j n minus 1 minus I. So I'm just going till the half because anyway if I go to the next one it will again be a duplicate, so we don't have to do that. So ij is here means here j n minus 1 minus I, n minus 1 minus j, and n minus 1 minus j I. So these are all the matrix. So with the movement of j, I am able to control all my index here. Why did I keep minus a is, you see a, b, c, d are the elements we got. We want to know the values, right? So if a is 0, b is 1, c is 2, and d is 3. So if I want to know the operations, I can simply say that if I want to convert from a to d, I need 3 operations, right? So I can take 3 minus 0, 3 minus 1, and 3 minus 2. So in order to get the integer value, I'm subtracting it with the ASCII character only. Now what do I do? After doing all of this, I'm doing sorting it. I'm taking all the corners first, all the 4 elements, then pushing it to a temporary vector. Then I'm converting it to integers and sorting it. What do I do? If I sort it, what is actually happening? These are the actual values. In numbers, I'm sorting it. I know that D is the value I need to keep across everything. A, B, C should be converted to D. So I sort it, I get the highest value. After I get the highest value, I want to know the number of operations. So to know the number of operations, I just subtract 3 minus 0, 3 minus 1 and 3 minus 2. You add everything, at last you get the number of operation. Now, we are able to get for all these 4 characters. On the next j iteration, what happens? You go to the next column. If you go to the next column, the index will be here, the next index will be here, the next index will be here, next index will be here. Similarly, you go for everything. J less than n by 2, it stops. Now it goes to the I next element. It goes here, and it just keeps incrementing. I becomes 1 here, right? Now that is the total iteration. Then it goes, these 4 index will compare, and we'll just keep working it. So that's all, guys, and I hope this is the problem solution, and I hope it's clear. So if you have any doubts, please let me know in the comments. We'll be glad to help. Thank you.